So this is the sheet on Unit 6 about circuits, and it's simple series circuits. So remember that when we're talking about a series circuit is that the current will be the same through every bulb or every resistance in the circuit. So there's a few units here that I want to remind you of. Volts is measured in joules per coulomb. Current, and again, I use I sometimes. Your teacher is using C. So C is coulombs per second. And then power is joules per second. So we have coulombs per second, joules per coulomb. And then if you remember, if you multiply voltage times current, the coulombs will cancel and you'll end up with joules per second, which is a unit of power. And a joule per second is a watt. Now, in number 1, they gave us a resistance of 6 ohms. And then they want to know how many joules does the light bulb take from each coulomb. That is actually asking what is the voltage drop across that bulb. So if the current is 2, and here's the current, 2 amps. If the current is 2 and the resistance is 6, then the voltage drop would be 12. So this would be 12 volts. Now, the current's going to be the same. So at A and B, the current is going to be 2, and at B, it will also be 2. How many joules does each coulomb have at A? Now at A, it's already gone through the bulb, so this would be 0, but at B, it would be 12. How many joules does each coulomb have at the ammeter? Now, at the ammeter, that's going to be here, so that would be 12. So, how many joules does each coulomb have at point A? A, joules per coulomb, the voltage here, it's already gone through the bulb. B, it hasn't gone through the bulb. Now, what is the brightness of the bulb? Brightness has to do with power. Power is current times voltage. So the current here, the current is 2, and the voltage is 12. So this would be 24 joules per second, which would be 24 watts. Now, in question number 2, here in the circuit, there's 10 coulombs that pass point A every 2 seconds. So that would be 10 coulombs every 2 seconds. That would be a current of 5 amps. Okay, so we have 5 amps here. Now, that 5 amps is going to be through the whole circuit. Now, how many joules does each coulomb have at the following points? Now, the voltage is 20. Here it has not gone through the light bulb yet, so that would be a voltage of 20. That would be a voltage of 20. At B, it would be 0. How many coulombs pass each? How many coulombs per second? That means current. So at A and B, it would be the same. That would be 5 and 5. And then what is the resistance of the light bulb? We know that voltage is current times resistance. Okay, what is the resistance of the light bulb? We know that the voltage is 20, and we know that the current is 5. So that means that the resistance must be 4 ohms. What is the brightness of the bulb? The brightness means the number of joules per second. It's a unit of power. So we're going to take the current, which is 5, and the voltage, which is 20, and that would be 100 joules per second, which is actually 100 watts. In number 3, we're given the information in a graph. Notice that it is linear here, so the rate of change is constant, and I drew these little dotted lines here. But this is probably the easiest one to focus on. If the voltage is 10, then the current is 2. If the voltage is 10, the current is 2. So if the voltage is 10 and the current is 2, that must mean if it's 10 here and 2 for the current, here's the current, that must mean that our resistance is 5 ohms. So the resistance here is 5 ohms. Now, notice that if you took each point here, you could do the same calculation. Now, if the current is 4 amps, okay, if the current is 4 amps, so if we continued this graph and we went up to 4, then instead of 210, it would be 420. All right, so joules taken from each coulomb would be 20 volts. Now, if the light bulb now takes 30 joules per coulomb, then what would the current be? So in each case, if you have 20 over 4 or 10 over 2, then 30 you would have 6. So what would be the current in that circuit? And that current would be 6 amps. Here we're given the resistance of 20 ohms, and we're given another of 25. And again, we're told that the voltage is 9. So again, the current at any point in this circuit is going to be the same. Now, if we want the current to be the same in both circuits, and you only have one bulb here, then this resistance would have to be the total. It would have to be the same as the total here. So bulb 3 would have to be 45 ohms. And then it says, what is the number of joules every second? So joules per second would be the power. Coulombs per second, joules per coulomb. Okay, so how many joules each light bulb emits? Well, if we multiply the current times the voltage for each bulb. So this one is, we said, was 45 ohms. Okay, now what we need to do is figure out what is the current through each one of these. Okay, so I'm going to say that the current through bulb 1 is the same as through current bulb number 2. Okay, and here, if the voltage is 9 and the resistance is 45, then I can say that that's going to be the voltage 9 divided by a total of 45. So if you take 9 divided by 45, you get 0.2. So the current here is going to be 0.2. Now, we wanted this current to be the same thing also. So this turns out to be 0.2 also. The current here is 0.2. Now, the voltage for each one of these is has to be the voltage here plus the voltage drop here has to add up to 9. So if I figure out the voltage drop for the first one, okay, I'm going to write it over here. So the voltage drop for bulb number 1 would be 20 times 0.2. The voltage drop for the second bulb would be 25 times 0.2. And if you notice, this turns out to be 4. and then this one has to be 5. Okay, and 4 plus 5 gives you a total of 9. And this one, we know that our voltage drop is 9 because there's only one bulb. Okay, now I'm getting a little bit out of room here, but let's look for power of 1 would be the current, the power through bulb number 1 would be 0.2. The current times its voltage drop would be 4. So the power would be 8. 0.2 times 4 turns out to be 0.8. For the power in bulb number 2 would be 0.2 times the voltage drop of 5. And then the power for bulb number 3 would be 0.2 times 9. Okay? So again, the current for all three is 0.2, but the voltage drops are different for each one. Okay, so this would turn out to be 0.8, this would be 1, and this would be 1.8. And again, joules per second is power. For number 5, bulb 1 has a resistance of 15. And we're given 4 coulombs every 5 seconds. So 4 coulombs for every 5 seconds. That would be a current of 0.8. Okay, 0.8, a current of 0.8. So how many coulombs per second are passing at A, B, and C? It's going to be the same. So it's 0.8 coulombs per second. Now, how many joules does each light bulb take from each coulomb? Well, from bulb 1, the current is 0.8 and the resistance is 15. Now, 0.8 times 15 gives you 12 volts. And if the total here is 20 volts and this voltage drop is 12, that means that the voltage drop for bulb number 2 must be equal to 8 volts. So because it has to add up to 20 volts, if this voltage drop is 12, then this one would have to be 8. Now, how many joules do the coulombs have at A, B, and C? At A, they haven't gone through any bulb yet. At B, they've only gone through 2, so they would still have 12 volts left because they've dropped 8 here, going through 2. And then at C, this would be 0. Now, what is the resistance of light bulb 2? Well, we know that the voltage drop is 8 volts. Okay, we know that the voltage drop is 8 volts. So if current equals volts over resistance, then that means that CR is equal to V. And if the voltage is 8 and the current is 0.8, then we can figure out what our resistance would be. So if you take 8 divided by 0.8, that means the resistance would be 10 ohms. Okay, now let's just check that. If you take 10 plus 15, you get 25. And 20 divided by 25 gives us the 0.8 that we had originally. Now in part E, how many joules per second does each light bulb emit? Well, our power would be our current, which is 0.8. 0.8 for both of them, but our voltage drop is for bulb number 1. For bulb number 1, our voltage drop is 12, and for bulb number 2, our voltage drop is 8. So this should be 9.6, and this should be 6.4. Now again, this is joules per second, and this is joules per second. Okay, number 6, we're given the resistance of bulb number 1 is 25 ohms and 15 for bulb number 2. So if the voltage is 30, then we know that the current going through the circuit, okay, the current is going to be the same at any of these 3 points. The voltage is 30. The total resistance is 40. So that means that it is 0.75 amps, 0.75 coulombs per second. And then the voltage drop for bulb number 1 and bulb number 2, the voltages of these two together must be 30. So voltage 1 plus voltage 2 has to be 30. And we can get the voltage by taking the current multiplied by the resistance. So 0.75. And if we're looking for V1, the voltage drop of 1, it'd be 0.75 times 25. And then V2 would be 0.75 times 15. So if you multiply these two, the voltage drop here is 18.75. And then if you take the voltage drop of the other one, this has to be the difference between 1875 and 30, and you get 11.25. So these are the two voltage drops. Okay. In number 7, how many coulombs are passing each point? Well, we have 12, 20, and 10. So the total resistance is 42 ohms. Now, coulombs per second, that's a measure of current. So what we can do is we can take the voltage, which is 16, and divide that by 42. So if I take 16 divided by 42, and I get about 0.38095. Now, I'm just going to take this to be 0.38. Again, we have 12 ohms, 20, and 10. So that gives us 42, and we have a voltage of 16. So it's about 0.38. And since it's a series circuit, then the current's going to be the same here. So this would be 0.38, 0.38, 0.38, and 0.38. It's the same through each one of them. However, how many joules does each light bulb take from each coulomb? Joules per coulomb is the voltage drop. So we're going to take 0.38 times 12. Times 12. And then we're going to take 0.38 times 20 and 0.38 times 10. And if we do that, then we will get 4.56. And then we will get 7.6. And this gives us 3.8. And if you add those together, you can confirm this, that if you have these three together will actually add up to, they'll add up to 16. Very close to 16, not exact because we rounded off. Now, how many joules do the coulombs have at A, B, C, and D? At A, they have not gone through a light bulb, so they have 16. Now, here, they have lost 4.56. So, if you take the 16 minus 4.56, that should be 11.44. And then through this one, they're going to lose 7.6. And so that would be 3.84. And then when they go through that last one, then they're down to 0. Okay?